In this lesson, we are going to continue working on solving trig equations, and specifically now we're going to look at quadratic equations. So let me just remind you quickly that when we are solving linear polynomial equations, we isolate the x on one side and use opposite operations to get x by itself. Okay, so x equals 3/4. So when we were looking at linear trig equations, we use a similar process. So we would want to isolate the sine x, or whatever trig function it is on the left, but then we have to, of course, take it one step further and we actually have to solve for x, right? So 3/4 doesn't come from any special triangles, so we know that we're going to be using our calculator in radian mode to get our answers. The sine function is positive in quadrant 1 and in quadrant 2, and so we're first going to use our calculator. We're going to punch in our sine -1, or our inverse sine of 3/4, to get our first answer. 2 decimal places, please, which is 0.84 rad. And then we're going to get our related angle in quadrant 2, so we're going to do pi minus 0.84 to get our second answer, which is 2.29 radians. Okay, so that's what we did last day, looking at linear trig equations. So now, similarly, we're going to look at quadratics. So hopefully it makes sense to you that there are two methods to solving our quadratic. First method would be that we would factor on the left, and this is just a trinomial, a simple trinomial, in fact, a perfect square trinomial. So there's actually only one value for x here. X equals 1. Okay, and you would be done. So similarly with trig functions, you would look to factor if possible. Of course, if factoring doesn't work, then you would move to the quadratic formula. So let's go ahead and solve this one on the right as a trigonometric degree 2 equation. So first step, we're going to factor. So same thing, this would end up as cos x minus 1, cos x minus 1. And if you need to, one of the things that you can do here is you can do a let statement. So you could let's say y equal cos x, and you could replace it to help your factoring. So this would become y squared minus 2y plus 1 equals 0. If you need to do that and to help see the factoring, then that would be okay as well. Okay, same thing as on the left here. This is really cos x minus 1 squared. And so we only really end up with one solution of cos x minus 1 equals 0. Cos x equals 1. Okay, so we've isolated our trig function, and now we need to actually go ahead and solve for x. So remember, cos x equals 1, that comes from our unit circle. Okay, cos x equals 1 at this point over here, right, the x value. So our answers here for x, if we were looking at one rotation, would be 0 and 2 pi. And that's where that domain in the question is going to be important. Okay, 4 pi would also be an answer, 6 pi, and so on. Okay, so let's try a couple of these together. So our note right here that we just want to write, the idea here is that with quadratics, we are going to look to set it equal to 0. Okay, and we're going to use our factoring or our quadratic formula, and we're going to solve sort of each piece, I'm going to say, or each binomial or each trig function. Okay, so this first example might not look like a quadratic to you because it doesn't have a squared like normal, but because there's a sine x times a cos x right here, it is still considered a quadratic. It's kind of like having an x and a y in an equation and then looking at factoring, right? So this would be sort of similar to an x, y minus x equals 0. Okay, I wouldn't actually replace that here. I just want you to understand what it would be similar to in terms of polynomials. Okay, so hopefully you can see that the correct method here in this first one would be to common factor out a sine x. So then we are left with cos x minus 1 equals 0. And what I mean by solving each piece is then you're going to solve this left piece, sine x equals 0. And you're going to solve this piece, cos x minus 1 equals 0. And all of the answers that you get for x are your solutions to this equation. Okay, so pause the video, go ahead and solve each of those pieces. You should be able to do that based on the previous day's work, so try that right now. So I always like to have that unit circle picture here on the left in front of me when I'm going to solve these ones that are zeros or ones. So sine x equals 0 when the y coordinate is 0. And you'll notice here that in the question given, the domain was between 0 and 2 pi. So do watch out for that. So that means one full rotation, like I'm looking at in terms of my picture. And so the y coordinate is 0 at 0, pi, and then 2 pi, right? So the solutions... Sorry, I had begun to start it here. The solutions for x are 0, pi, and 2 pi there. Okay, now in terms of when cos x equals 1, that's when my x coordinate is 1. So that would be right here. Okay, so here my solutions for x are 0 and 2 pi. Okay, so those are all the possible answers that satisfy this equation, all of the x values or the angles that satisfy this equation. So you would want to conclude in this question, make sure it's obvious here that the solutions for this equation are 0, pi, and 2 pi. So you do want to merge those answers together there. And obviously you don't need to write the same ones twice. Okay, let's try another one. To that picture over there. Okay, so now I am looking at the picture. Sine x equals 1 is up here. Right, the y coordinate is 1, so just pi over. Okay, so here in this next one, you can see it's quadratic. It's all in terms of sine. So if I was going to do a substitution, I could do let y equal sine x. And then this quadratic would become 2y squared minus y minus 1 equals 0. So you're solving that by factoring. Okay, so do yourself a favor, try and pause the video and see if you can get it factored by yourself. So when I do it without the substitution, I know I'm going to factor it to be two binomials. My first term is 2y squared or 2 sine x squared, so I know that that's going to be made up of 2 sine x and sine x. You don't really have any other options. Same thing for the 1 there at the end. I know there's going to be a 1 times a 1, and then I just need to make my signs work, right? So I need it to be minus 2 and then plus sine x, minus 2 sine x plus sine x to make that work. So that's how I do it without doing that substitution, but whatever you like, if you need to do that at the side of your page, that's great. Okay, so let's go ahead and solve each piece. This piece on the left here becomes sine x equals negative half. So I know negative or a half comes from my special triangle that looks like this. This is my pi over 3. This is pi over 6, 1 root 3, 2. So if I'm dealing with sine, then I'm looking at pi over 6, right? So pi over 6 is my related acute angle, my beta, if you like, is pi over 6 for sine x equals a half. But since I'm dealing with negative a half, I know that I want the quadrant 3 answer and the quadrant 4 answer according to the CAST rule, right? That's where sine is negative, and quadrant 3 and quadrant 4. Again, this is me looking at my formula sheet and all of those tools in front of me. So the two related angles in quadrant 3 of pi over 6 is 7 pi over 6. One more than 6 pi over 6 is how I remember it. And then the other one is 11 pi over 6, one less than 12 pi over 6. That's sort of how I figure those out in my mind there. So those are two of my answers. The other two answers are going to come from the right binomial, sine x minus 1 equals 0. So sine x equals 1. And here then, again, I'm looking at my picture from above. Is my answer for that one. So here x equals pi over 2. So I was looking at that unit circle, axes, arms, if you like. Again, a nice conclusion here. You want to combine all the values. It is customary for them to put them sort of in numerical order from least to greatest. That's not something that I'll watch out for too much, but that is how the answers will be posted if you find them. So we would put our pi over 2 first, and then our 7 pi over 6, and then our 11 pi over 6. Okay, and because those are all exact values, you don't need to include the rad, it's implied, but if any of your values are decimals, that's when you would include your radians. Okay, so today we're going to practice a whole bunch of these quadratic ones. We're going to look at some more together a little later. Right now, your task would be to try a couple of these and begin working until we meet again.